Hi, uh, today we'll discuss about the data modeling, how to model and how to design a database. And actually, it's a very important, and I should say the most important step in designing a database or data-related application, because uh, database is working at the back end of the application, and the application is just merely a front end, and we have to work according to the what the database we have designed. So if a concrete database design is there that is that doesn't have the redundancy and that has the integrity in it, then the application development is much easier and much robust. So I'll start with a very basic database so that everyone can understand that how to design a database. So let me start with a generic database. Let me scan as TBL books. Okay, the application we are trying to, or the model we are trying to build, the data model we're trying to build is for a library, for a library automation system or simple library. Why I have chosen the library? Because it has it's much simple and everyone knows, and I'll be like discussing very basic ideas that everyone is familiar with in a library. Actually, we'll be actually building or designing a database for the books actually. So we all know that in libraries we have books. The libraries just has a collection of books where we can find the books. So in libraries we have books. So every book has a book ID. Let's first define the entities. What are the basic entities in a library? We are not concerned about the staff, we are not concerned about the building, we are only concerned about the basic thing, the basic entity in the library, and that basic entity is book. That's why we have chosen the name TBL books. So let's now, we have taken just one entity of the library, that is books. Now let's explore the properties or fields of the book. So first of all, every book should have a book ID. So let's do it, book ID. We'll first just identify the basic entities and then we'll refine, and in technical terms it's known as normalization of the database. So initially we'll simply identify the fields or the basic fields in the books table or in the library related to the books, and then we'll refine the data model, and and technically it's known as normalization. And beside that, I'll be discussing and I'll be telling that why there should be multiple tables, how to build the relationship among them, and so on. So let's go through the basic fields in the book. It should be book ID, or we can also take, it can also be an ISBN number, but we should take a simple auto number book ID instead of ISBN number because of some reason that I'll discuss later in the video. Let's say that there's also a field ISBN number. We know that every book has a special number, a unique number, so this field is unique. We can also you can also make it as a primary key ISBN number because it's always unique for every book. But let's currently take the book ID auto-generated number as a primary key, and ISBN it's a unique field, and it's with it's available with every book, most of the book, the international books. Okay, then every book has a title that we all know. Then the book has been written by some authors, let's say authors. Then there is another field that book is related to some subject, so we also write we also add a field named subject. And definitely some publisher has published the book. We can also add many more information regarding the books, for example the number of pages, the price, and many other things, but currently just stick to these main fields. These are the very important fields that must be there for every book, and that is always there for every book. There's always an ISBN number, and there's always a title of the book, and someone has written the book, so they are authors. And book is regarding some specific subjects, and some publisher has published the book. Okay, now let's have a look at it. That for every book we have a single ISBN number. We cannot have multiple ISBN numbers for the same book. How many copies, whatever number of copies are there that are published by the publisher, all of them would have the same ISBN number. Then a single book will have always a single title. It will have a title, whatever, introduction to database or introduction to programming, or whatever that title can be. So we don't have any problem, and everything is going perfectly fine till now. But what about the authors? Every book has an author, but is it necessary that we should only have one author? No, we can have multiple authors. Now the problem is how many authors are or can be. There can be 2, there can be 1, there can be 3, 4, 5, 6, any number of authors. So how to tackle this issue? How to store the names of all the authors related to that book? Either we can do it like author 1, author 2, and author 3. Let's say if we say that it's like that author 1, author 2, and author 3. But what if we also have an author 4? And on the other side, what if we only have one author? What would be stored in these two fields? These are not required for that specific book. It doesn't have more authors, so it's not the way to store the data. Whenever we have multiple values for a single field in a single record, if for a single field we can have multiple values in a single record, then what we should do, we should add a new table for that. So what we should do is to add a new table. So let's go and create a new table. Click on the table and right click for design view. Let's see TBL authors. Moreover, if even and that would be more elaborated, that what I'm going to say is that if for a single field we can have multiple data for that. For example, an author is normally affiliated with some organization, for example specifically with the textbooks or the books related to the studies. The authors are related to some universities or colleges or schools, whatever they are. So in the same case, what we can do now, you can create an ID, author ID, that is an auto number, and then we can say author name. Now we can also add another field for more affiliation, for where the author is affiliated, or we can add more information regarding the author, for example email address, phone number, whatever. But these the author name and the author ID is the most required information that we need. So we are done. Now we can have any number of authors, and then how we can relate the one author to this book. We will see it later when we will complete the modeling of the database. Okay, now every book, most of the time the book is related to some subject. So again, here is the problem. One book might be addressing multiple domains or multiple subjects. For example, if there is a book, database modeling or database designing and programming with C# or database designing and programming application development with VisualStudio.net. Now this specific book can be related to more than one fields. For example, its subject can be the programming, its subject can be, or tag can be the C#, its tag can be the database modeling or database programming. So there might be multiple subjects. But if we go to the broader categories, a book might be useful for the mathematics students. Same book might be useful for the engineering student. That specific book might be also useful for the computer science students. So our book may lie in multiple subjects. So again, using the same rule, that when we have multiple values, there can be multiple values for a single field, we should create a new table for it. So let's go to the create table, open design view and give it a name, tbl subjects. So again, here is the subject ID, that will be the author number, and then subject name or title, or simply say subject, and we are good with it. We can always add more fields, but that's the requirement. Okay, then publisher. Normally a single book is published by a single publisher, so we will stick to that specific thing. But for the publisher, we may want to store more data. For example, there is the publisher name, there might be the publisher address, there might be some other information regarding publisher. So if even we add the publisher address here, it's perfectly fine. For example, let's try to save some data, for example in TBL books. Okay, the book ID would be automatically generated. Let's say its ISBN is 1, title is ABC. Let's say now authors are ABC. We will be going to change the authors field actually. Let's say subjects is XYZ, the publisher is P1, and publisher address is blah blah blah. Okay, here we are done with the first thing. Now again, give another book to, title is CCV, authors are ERE, any author, subject is again XYZ, publisher is again P1, and publisher address is blah blah blah. Okay, if you look at it, that information is necessary. Like for every book we need to have the publisher. But if you look at this, the publisher address, that is repeating, and that repetition is not required. That can be get rid of. We can get rid of this repetition because it's taking much space. For example, in terms of space, it would be taking at least 15 bytes, because every character takes at least 1 byte. So we can get rid of this information, and and this is known as redundancy in the data. Like there is the redundancy in the data. This is also a sort of redundancy, but we cannot avoid it. But we can avoid this redundancy. That how we can avoid it? So we'll simply go to TBL books and we'll remove this publisher address, and we'll add another table, and that is TBL publisher. So we can say it as publisher ID, and then we can say publisher name, and then we can publisher address, publisher email, and whatever fields we want to add regarding the publisher. So now we are good with basic things. For example, we started with a simple book table, identified the fields in it, and now we identified the 4 or 5 books fields: ISBN, title, author, subject, publisher, and now we are ending up with at least 4 tables. But there's one good thing about it. Let's delete this thing. There's one good thing. If you look at the authors table, you'll find it totally independent and a very nice table, which is only storing the author's information. Then we have the publisher information. Now we can simply add some publishers here. There are a limited number of publishers: 10, 20, 100, 200,000, and so on. And then there are multiple subjects. All the subjects can be added in the subjects category, and so on. So now what we need to do is we need to relate all these tables together. Okay, and a good way for it is to create the relationships, and let me now change the TBL books, because I'll be going to okay, let me do it later. Let's go to the database tools, and actually we try to make relationships among these tables. So click on the relationships and add all of the tables here, and then we'll say what's the relationship. So if you think that our main aim is, or the main entity is TBL books. Okay, just a minute. Okay. Our main entity is TBL books. All these tables that we actually created and we derived from the information that was related to the book. See, the ISBN of the book, there is no problem. Every book would have one ISBN, and that would be perfectly fine in this table. Title is a book would have only one title, but there might be multiple authors. So here what we'll do, we'll change the TBL books is already here. We'll change. Now we don't want to add the name of the author. Rather, what we'll do, we will create a relationship in a sense that we'll take the author ID from this table and we'll add it here to identify that what books who are the authors of that specific book. But still we are stuck with that problem that we can add only one ID. So let me first add some data, and then we'll create some we'll create the relationships among them. So let's go to the TBL authors, open it, and you say author name is, let's say some author, for example, we can say it's Robert Lefort. and affiliation with, let's say, we can say it as NDSU, any institute. Then another author, William Stallings, and the affiliation is with let's say MIT. Then we can say Tannenbaum. I don't remember the exact spellings, but let's go through it. And he's with the UC Berkeley. Okay, so we are good with the authors. Let's save them. Now we'll go to the publishers, add some data. Publisher name, let's say it's Prentice Hall, or okay, Prentice Hall. I don't remember the publisher address. Let's say New Jersey. There can be McGraw-Hill. McGraw-Hills, let's say they are from New York. Let's say there's Elsevier, they're from Holland. So we are good with some of the publishers. Let's define some subjects. For example, subjects is computer networks. We can say programming, and we can say as programming, database development, and let's say there are these subjects. Okay, now we want to define a book. Okay, there was initially authors, so let's leave it as it is. Okay, let's say we have a book, Introduction to C++, and the author is Robert Lefort, and the subject category is programming. So let's just write here. For example, I'll be writing, for example, the book's details here, and then we'll add it to the database. We say that we have a book, Introduction to C++ by Robert Lefort, and the subjects are programming, or the category is programming. And let's say we have another book, Introduction to Network Programming, and the authors are William Stallings and Tannenbaum. And definitely now you can just, as you can find from its title, that this book is related to programming, and it's also related to the networks, computer networks. So now we have two books that are very simple books. Now we want to store that data in TBL books. Okay, ISBN is fine, we can give any ISBN. The title would be fine for even for the Introduction to C++ by Robert Lefort. We can write it here, Introduction to C++, and in authors, now we don't need to write Robert Lefort. Rather, we can just write here author ID, and when we will give the author ID is 1. It means that this field, this author ID field, is attaching my book with the author ID, and by using that author ID I may know all the details for that specific author, that what's the author's name and what it's to which department or which university or which school he is associated with, and so on. The things are good here. Moreover, the subject is programming, and here also now we'll not write programming, rather we'll use the subject's ID, that is programming 2. And then what we'll do for the publisher, we can say that it was published by elsewhere, whatever. So things are good for the record 1, the introduction to C++. But what about the introduction to network programming? Let's try to fit this second book in the same data. Now we can write the title, introduction to network programming, and what about to do with the author? Now it was author ID. We can add 1, and it should be integer or number, whatever it should be. I think it would be number. Always remember that whenever there is some field, foreign key, that we will be going to build a relationship, using which we will be going to build a relationship among tables. The data type of both the fields in the primary table and the secondary table, this should be same. That should always be same. So if we are using here author ID, and the author ID field in the main table, primary table, is integer or the number, it must be number, or it must be number in TBL books, or whatever the secondary table is. But here is the problem. We can add one field here. For example, if you want to open it, now we can give ISBN, any ISBN 111. Title is network programming, let's say, whatever, introduction to network programming. And the author ID we can say that it has been authored by William Stanley and Tannenbaum. We can write here 2. We can give here value 2, it would be fine. But how we'll give the author ID of Tannenbaum? That is the 3, because there were 2 authors there. And same in the case of subject, we cannot give the IDs of 2 subjects. So in technical terms, this situation is known as that there is many-to-many relationship. Many-to-many relationship means that there might be multiple records. How this can happen? For example, a book can be written by one or many authors. So the relationship between the book and the author is 1 to many. A single book can be authored by multiple authors. Multiple authors, single book, it's possible. So it's 1 to many. But at the same time, a single author may author multiple books. So again, the thing is that a single book might be authored by multiple authors, and one author may author multiple books. For example, a single author, Tannenbaum, may write introduction to network programming. He may also author distributed system. He has also authored actually distributed systems, computer networks, operating systems, and so on. There, a single author has authored multiple books. And a single book, for example, taking the example of distributed systems by Tannenbaum, it has 2 or 3 authors. Similarly, all the books by the Deitel and Deitel, that how C++, how to program, Java, how to program, all the books by the Deitel and Deitel, it has the books have multiple authors. Harvey M. Deitel is one, and the other one is, but at least there are two authors there. So the relationship among the TBL books and TBL authors is many-to-many. There is a many-to-many relationship among these both tables. So whenever there is a many-to-many relationship, to make the relationship one-to-many, because the relationship between any two tables must be either one-to-one or one-to-many. There cannot be many-to-many relationship among two tables. So whenever there is the situation that there is many-to-many relationship, we need to add another table. We say it as bridge table to break the many-to-many relationship. So here we are adding the bridge table for TBL book authors. So what the book authors should have, it should have, let's say it has an ID number, then we say that there should be an author ID, that is number, and there we can add book ID, and book ID is also a number. So when we'll create this field, now what we can do, and similarly in case of the subjects, specifically one book might cover multiple subjects, and definitely in the library on one subject will have multiple books. So see, again here is the multiple many-to-many relationship, that a single book might be discussing multiple subjects, and a single subject might have multiple books in the library. So again the relationship is many-to-many. So again here what we'll do, we'll add another table to solve the issue, and now this is also a bridge table to solve the problem of many-to-many. So give TBL book subjects, and whenever we add the bridge table, we simply add the IDs of the primary keys of both the tables that we are bridging together. So we'll also add here book ID, that is number, and we'll add here subject ID, that is also a number. And now we don't need the author ID here because we have created a separate table for it. We also don't need the subject because we have also created a bridge table for the subject. But let's stick to the fact that one book is published by a single publisher. Book is always published by a single publisher. However, one publisher might publish multiple books. So there is a relation between the TBL publisher and TBL books is one-to-many. Only one book, like a single book is published by a single publisher, and if a single book is published by multiple publishers, then we also need to add, and means if there is a many-to-many relationship, then we also need to add one more bridge table. But here normally is the case that a single book is published by a single publisher, so the relationship between the TBL books and publisher is one, and between one-to-many, one book by one publisher, and one publisher may publish many books. So here one, here many. And now it also one-to-many thing is let me remove this one because it's the old one. Let me save it, and now we will go to the relationship section, and now we'll add more two tables, the bridge tables, TBL book authors and TBL subjects. Now always remember the case. Now which, here we have, see, we for a very simple thing we have created 6 tables, but using this technique, now the data would not have redundancy and the data would have the integrity. Now how to create the relationships? Like what do we mean by relationship? That we use primary key of one table as the foreign key in adult table. So whenever we have one-to-many relationship, always there is the case that the table that has one, like let's just think that a single book, a single book is published, a book is published by a single publisher, but the publisher may publish multiple books. So here is the relationship one to many. A single publisher, many books. One book, one publisher. So what we need to do is that one publisher, multiple books. So we'll drag, or we'll take this publisher ID as the primary key, and we'll use it as a foreign key in the book table, because the relationship is one-to-many from publisher to books. So here table query is publisher ID and related table query is publisher ID, and here we can say enforce referential integrity. So what do we mean by enforce referential integrity? For example, we already created some relationship. Let's say there was a publisher like Elsevier or Spring or whatever, and there were many fields, it was referred by many books, like they published many books, and now accidentally or deliberately we deleted the Springer from our publisher table. So all the records in the books table that has the ID of Springer, the publisher that we deleted, will become invalid, because for those publisher IDs we cannot find any data. So when we enforce the referential integrity, we make sure that if something is deleted or changed in the main source table, the changes should also be made or occur in the reference or the secondary table. And that's what we say cascade update related field and cascade delete related field. For example, if we'll delete now, when we click create, it has been used. So let me close it first, and also close all. Okay, just it's simple in Access to create a relationship. Just drag the primary key of main table to the key of the secondary table. And I was talking about the enforced referential integrity and the cascade. When the cascade delete related records means when one record from the publisher is deleted, that all the records that have that specific publisher as an ID in the secondary table, those are also deleted automatically. I'll show you this after some time. So just click on create, and you can see that one-to-many, this infinity shows one-to-many relationship. So now we have created successfully a one-to-many relationship, and in Firebird or other databases we can create it by creating a constraint of foreign key. So it's the same thing actually in the back end. The same thing happens, but the Access just provides a GUI based tool for the ease. So now what should be the the relationship? If you look at the TBL subjects and book, and here let me, as the book is the central table, so let me put it in the center. So now we have one author, but here we cannot find any author, so we have created a bridge table between the book and author. So one author could have only one book in a specific record, like we'll just copulate the author ID and book ID. So here what we'll do, as it's a bridge table, whenever we'll create a bridge table, we will take the primary key of the primary table and drag it to the, or create it as a foreign key in the bridge table. So we'll do is this, also create referential integrity, and then we'll do the same for the book ID. We'll take it here, book ID would be added here. Similarly, we'll do the same thing, like the book ID of the TBL books to the TBL subjects, and then the subject ID from the TBL subjects to the TBL book subjects. So now we have successfully created all the relationships. Now let's go and try to add the data. We already have added the TBL authors, the TBL publisher, and TBL subjects. We will now go to add some books data. So here what we were doing, ISBN 111, Introduction to Network Programming. And let's say publisher ID is 1. Again, now the data is not yet completed because we haven't stored the author's information and the subject's information. So click on the TBL publishers, the TBL book subjects, and we also open the TBL authors and TBL subjects, TBL publishers to know. So what subjects it was related to? It was related to computer networks and programming. So what I'll do in TBL book subjects, that the book ID, we already know that the book ID is 3. So we'll add it here, 3. And the subject ID here would be 1 for the computer network, and we'll again the book ID 3 and the subject ID is also 3, because now you can see that a single book, means book ID number 3, that was Introduction to Network Programming. Here we have added, or we have related it with 2 subjects, subject ID 1 and subject ID 3, and subject ID 1 was computer networks, and it was not, it should be 2, not 3. So we have successfully related the book ID 3 with 2 subject fields, 1 and 2, means computer networks and and programming. So if even it discuss the database development or TCP/IP or whatever, we can now now we have the freedom to add as many subjects with a single book as we want. So that's the power and that's the use of the bridge tables. Similarly, in case of TBL book authors, for the author ID, for the book ID is 3, and the author IDs is Williams, Challenge and Tannenbaum 2 and 3. We'll add first the author ID 2, and then we'll say that for the same book 3 we have also the author ID 3. So if there are multiple authors, for example, there is some other author, let me add its name. Okay, one more concept, that we can only add the data or the record in the field, or the data in the field of a field when the field is when the field is a reference key that is referring from another table. For example, that the data already must be there. For example, if we want to say that for the book author 3, the author ID is 4, and if you want to enter it, you cannot add or change a record because a related record is required in table TBL authors. So unless we have so just click on escape. So unless we have an author with ID 4, we cannot add it in the TBL book authors or whatever, wherever it is referenced. So let add someone like title, and say he's also from MIT. So now if you want to add TBL authors as 4, like title has also authored the same book, now it would accept it and there will be no problem. So that is let's add another book, like for example ISBN is 123 and introduction to C++, publisher ID is, let's say, 2, and now we need to add the subjects. We know that for the book introduction to C++, the subject is only programming. So subject here is programming 2. So the subject ID for the programming category is 2. So we can add it here as TBL book subjects, as that the book ID now is 4 and the subject ID is 2. So there is no problem. In case of TBL authors, we can add that for the book ID 4, the author ID is 1. Okay, now let's save the data, and we have successfully added all these things. Now let's have a look at what if we delete a data. For example, if we delete Robert Lefort from the table authors. So let's delete record, and it's saying the relationship that specify cascading reads are about to cause one records in this table along with the related records in related tables to be deleted. So it means that when we'll delete the record from the main or primary table, all the referenced records that have referred to that specific record would also be deleted automatically. So let's say no. Okay, we can see that we have TBL books and we have 2 records here, and in TBL authors we have these, and in TBL book authors we have a record with book ID 4 and author ID 1. So let's now delete it, delete the record, clicked on yes. Now go to TBL authors, and you can find here that the record for the book ID 4 is deleted automatically, and that's what the enforced referential integrity and cascading delete means. Similarly, if we simply like here we can see that the publisher ID is 2. If we go and click on the publisher ID, and one important thing, that why the data is not deleted from the books, it's the reason is that the TBL books doesn't have any direct relationship with the TBL authors, so that's why it was but it has a direct relationship with TBL publisher. So let's go and delete TBL publisher with ID 2, that is McGraw Hills. We'll delete the record, and if we come again to TBL books, we'll see that the record is also deleted here automatically. But in programming, whenever we create or develop a front end for a database application, we don't need to like remember the IDs or specify the IDs. Rather, we use some nice drop down boxes from where we can select the subject, and the subject ID is automatically stored at the back end. So when we'll go through the programming area and programming lectures, then we'll look at it in detail, that how it happens. So today we actually learned a lot of things, and we actually gone through very fastly, and from many of the concepts in the database and in the database designing. But some of the things that you should remember in designing a database is that there should be in one record there should be only one for every field there should be only one value, and there should be one-to-many relationship among the tables, and if there is many-to-many relationship, break down the relationship in one-to-many by adding a bridge table. So we will also have another discussion regarding this subject, or we can also work more on, if you want, I'll add more tutorials specifically regarding your needs or questions, or whatever the confusions you have. Thank you very much.